Hey, 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 we got zero negative exponents going on today. A lot of fun stuff here, a lot of interesting math. We're going to get this figured out. Got a few side bits to give you. So let's go ahead and get started right in on it. We'll get started with zero power. It says any non-zero number that is raised to the zero power is 1. You notice it says any non-zero number. So if you have 0 raised to the 0 power, that's not going to be 1 because it is a 0 number. So any non-zero number that is raised to the power of 0, the answer will be 1. So let's look here. 4 raised to the 0 power, that's 1. If you have negative 3 raised to the 0 power, that's also 1. Now what about this this multiplication inside the parentheses? 250 times x cubed times y squared. Well, you know from the last section, if you multiply all those by 0, you're going to get 250 to the 0 power, which is 1, x, and then 3 times 0, or x to the 0 power, which is 1, and then y, 2 times 0, which is 0, is 1. So you just have 1 times 1 times 1, or you know that this right here is one number because they're all being multiplied, so it's going to be one number. So it's just this one number raised to the 0 power, or 1, however you want to think about it. The fourth example, x to the 0 power. Well, we don't know what the value of x is, but we do know that it's going to be raised to the 0 power, so it doesn't matter what number it is, as long as it's not 0, as long as x does not equal 0, that's going to be 1. Fractions raised to the 0 power, they're still 1. So basically, any number raised to the 0 power is going to give you 1, other than 0. You can't raise 0 to the 0 power. Or actually, you can raise it to the 0 power. It's just not going to equal 1. So, let's go back to asking this question here. Neil Armstrong. Neil Armstrong was the first human to step foot on the moon. So Neil Armstrong was asked the question one day, why did the chicken cross the road? And Neil replied, it was one small step for chicken kind and one giant leap for poultry. That's what Neil had to say about it. A negative exponent. A to the negative x power is the reciprocal of a to the x power as long as a does not equal 0. And so I've kind of laid it out here for you. We have a to the x power. What is the reciprocal of this? Well, we know a to the x power is over 1. And so what's the reciprocal of that? You flip it, and you're going to get this. 1 over a to the x power, but 1 over a to the x power is equal to a to the negative x power. So a negative exponent is going to be the reciprocal. There's a different way of thinking about this. I'm going to explain that to you when we start working on the problems. But as long as you know that a negative exponent is going to be the reciprocal, that that concept is useful also in some problems that we come to. So don't forget that. Negative exponent. A to the negative, here's the definition again. A to the negative x is the reciprocal of a to the x as long as a does not equal 0. And this is what I wanted to explain to you. Why a cannot equal 0. Well, let's look here. Here is what we have. This is the definition in symbols. And a is going to be equal to 0 this time. A cannot be equal to 0, and I'm showing you why it cannot be equal to 0. So if you have 0 to the negative third power, the reciprocal of this is going to be 1 over 0 to the third power. Well, you know 0 to the third power is 0, so we're just going to have 1 over 0. And you cannot have 0 on the bottom of a fraction. Therefore, that's why a cannot be 0 when you have a negative exponent. All right. Here's the way I kind of tell you how to do it. Remember, you should always remember a negative exponent does mean reciprocal. But a different way of thinking about it is that you're going to move the number with the negative exponent to the other side of the fraction bar. Fraction bar. There's all right. So let's look here. First example, x has the negative exponent. So if x to the negative second is on the bottom of the fraction bar, let's move x to the negative second to the top, to the other side of the fraction bar. And when we do that, it becomes positive. The exponent becomes positive. So we just have x squared on top. Now, the 1 is still here. It's still, this 1 is still there. It's still 1 times x squared, but what is 1 times x squared? It's just x squared. And now, what's on the bottom of this? Remember, this is still like, on the bottom, it's still like 1 times x to the negative second power, which is just x to the negative second power. So there's a 1 down there. If we move some things around and there's nothing on the bottom, or if we move some things around, there's nothing on top, it's going to be a 1 there. So we have x squared over 1. The answer, x squared. Let's look at the second example down there. 3 to the negative fourth power. Well, if we have 3 to the negative fourth power, well, we have to move it to the other side of the fraction bar. Well, it's got to have a fraction bar first, so you put it over top of 1. Well, if 3 to the negative fourth is on top of the fraction bar, the other side would be to move it to the bottom. And since it's on the bottom, there was nothing on top. So if there's nothing there, remember, it's just like 1 times 3 to the negative fourth on top. That 1 is on top. Okay. Now 3 to the fourth power on bottom, well, we know 3 times 3 times 3 times 3. This is 3 to the fourth. 3 times 3 is 9. 3 times 3 is 9. 9 times 9, 81. So the answer, 3 to the negative fourth, is equal to 1 over 81. All right. Well, if we're going to be talking about some people, the next person that was asked, why did the chicken cross the road, is an artist, M.C. Escher. You might want to look up a few of M.C. Escher's drawings, paintings, to understand this next answer. When M.C. Escher was asked, why did the chicken cross the road, the reply was, well, that depends on which plane of reality the chicken was on at the time. Which plane of reality the chicken was on at the time. And if you've seen some of M.C. Escher's paintings or drawings there, you'd kind of understand. Move the number with a negative exponent to the other side of the fraction bar is what a negative exponent means. Now, I told you to also remember that a negative exponent means it's the reciprocal. So, if we have 1/2 raised to the negative first power, 1/2 to the negative first power, what is the reciprocal of 1/2? The reciprocal is 2 over 1, which is equal to 2. Okay? Now, let's take what we figured out from the last. I don't think we've done this. I think we'll do this in the next section. If you have 1/2 to the negative 1 power, this negative 1 goes with the 1 and it goes with the 2. So we have 1 to the negative 1 power, and we have 2 to the negative 1 power. And so if we move them to the other side of the fraction bar, that means 1 to the negative 1 goes to the bottom, and it still has a power of positive 1 there. It's just we don't have to write a power of positive 1. And 2 to the negative 1, it goes 2 will go to the top with the power of positive 1. Now what's 2 over 1? 2 over 1 is 2. So sometimes it's easier to remember that a negative exponent is the reciprocal, and sometimes it's easier to remember that if you have a negative exponent, you move it to the other side of the fraction bar. Those are things that you're going to have to just work with and practice with, and see if you can come up with the best way to get that done. Next thought here is the Los Angeles Police Department was asked, why did the chicken cross the road? And the LA Police Department, they said, you know what? You give me 10 minutes with the chicken and I'll find out. Yeah. They will find out with 10 minutes with the chicken. Well, I guess they got to find the chicken now. Because he crossed the road, who knows where he's at. Or she. Either one. Let's look here. A couple different ways to think about this. If you have 3 over 2 raised to the negative third power, 3 over 2 raised to the negative third power, you see the negative exponent? Well, it makes the reciprocal. What's the reciprocal of 3 over 2? The reciprocal of 2/3. Now, once you change it to the reciprocal, the exponent becomes positive. And then from here, the 3 goes with both of those numbers. 2 cubed, 3 cubed. You should be able to work that out. Now let's go back here. If we want to take that negative exponent and it goes with both numbers in there, so we're going to have 3 to the negative third power and 2 to the negative third power. Well, how do we think about this? Well, if we're looking at it, move the numbers with the negative exponent to the other side of the fraction bar. Well, 3 has a negative 3 exponent, so 3 comes down below, and the exponent becomes positive. 2 has a negative 3 for an exponent, so 2 is on bottom, it goes to the top, and it has a positive 3 for an exponent now. When you move it, it becomes positive. And you notice we're at the same step. 2 cubed, 2 times 2 is 4, times 2 is 8. 3 cubed, 3 times 3 is 9, times 3 is 27. Either way you think about it, the answers will still be the same. So 3 halves to the negative third power is equal to 8 over 27. Let's see if you can try and figure this one out on your own. Try and figure that one out. Pause the video and then I'll work it out. Okay, so we're looking here. If you have 1 over j to the negative 2a power, well, what has a negative exponent? Well, j has a negative exponent. So basically, j was on bottom and it goes to the top. And the exponent was negative 2a, so the exponent becomes a positive 2a. There's nothing left on bottom, so it's a 1. Remember, it is not this one, because this one is still on top as 1 times j to the 2a. So you have 1 on bottom there, and j raised to the 2a power divided by 1 is just j to the 2a power. So think about that. It went from the bottom, j to the negative 2a, went from the bottom, and it went to the top of the fraction bar, and it became a positive. Well, if we were to think there about why the chicken crossed the road, and maybe one day you want to sit down, have a chat. One time I sat down, had a chat with my grandpa, and this is what he said. Hypothetically, this is what he would have said. Why did the chicken cross the road? He would have said, in my day, we didn't ask why the chicken crossed the road. Someone told us that the chicken had crossed the road, and that was good enough for us. I guess back in those days, you just didn't ask questions. All right, if we look here, move the number with a negative exponent to the other side of the fraction bar. This type of problem is where that thought process comes in handy, comes in handy a lot. Because move the number with a negative exponent to the other side of the fraction bar. Okay, well, let's look here. We're going to have to go step by step and look at these numbers. Let's look at the 5. 5 has an exponent of a positive 1, so it stays where it's at. It stays on top. X to the 4th, it's a positive exponent, so it stays on the top. Now, y to the negative 3rd, right here's the negative exponent. You have to move it to the other side of the fraction bar. Move it to the other side of the fraction bar, and it becomes a positive exponent. All right, now let's go down on bottom. 5 to the negative 2nd power. 5 to the negative 2nd power, it's negative, so it's on bottom now. It will move to the top, and the exponent becomes positive. X to the negative 5th power, well, it's a negative exponent, and it's on bottom. So since it's negative exponent, we have to move it to the other side of the fraction bar. X to the positive 5th power. When we move them, it becomes positive. And y to the 7th, well, it's positive already, so it stays where it's at. And so this is what we have. And now let's go ahead and combine some like terms. Well, we know that this is 5, and 5 squared is 25. So we could say that this is 5 to the 3rd power because they have the same base, and you add those exponents. Or we could say 5 times 25 is 125, because we know that we're going to eventually do that at some point. Now, x to the 4th and x to the 5th, they have the same base of x. And so if they have the same base and you're multiplying, because all these operations are multiplying, what will you do with those exponents? You will add those exponents. So 4 plus 5 will give you 9. And on the bottom, we have a y, we have a y, and we're multiplying those. Same base of y. And what do you do with those exponents? You add those. Y to the 3rd times y to the 7th will give you y to the 10th. And there is the simplified answer to the beginning problem. Here's one. I want you to try this one on your own. Remember, take it step by step and figure out negative exponents go to the other side of the fraction bar, and the positive exponents stay where they're at. So you go ahead and figure that one out on your own, and pause the video and check your solution with mine. All right, working this out here. 3 to the negative 3rd goes to the bottom. A to the 4th stays on top. B to the negative 2nd goes to the bottom. And C stays on top. 3 squared stays on the bottom. A to the negative 1 goes to the top. and b to the 6th stays on bottom. Let's go ahead and put some things together. A to the 4th and a to the 1st. They have the same base, so you add the exponents. 4 plus 1 is 5. C is all by itself, so it just stays C. On the bottom, you have 3 cubed, 3 squared. 3 squared is 9, 3 cubed is 27. So 9 times 27 is going to be 243. And we have b squared and b to the 6th. They have the same base. So squared and 6th, you add the 2 plus the 6, and that gives you an 8. And this was your answer. A to the 5th power times c over top of 243b to the 8th. Okay, how about this thought here? Why did the dinosaur cross the road? Why did the dinosaur cross the road? Think about that one for a minute. Everybody knows the answer to this one. Dinosaur crossed the road because chickens did not exist yet. That's why the dinosaur crossed the road. I told you know it. I told you know the answer. Okay, let's look at this. I have 2 problems set up here, and they're the same problems. It's just I want to show you both ways on how to work them out. So if we look here, the way I like to look at these is the first method. Actually, you know what? I'll show you that the second method, so that way you have to go through the first method to see the difference and see which one you like. This one here, if you have this -1, if you have this -1 outside the parentheses, that -1 has to go with everything inside the parentheses. So it's going to go with -6 to the -1st power. It's going to go with a to the -2nd power to the -1st power. It's going to go with 3 to the -1st power, a to the -1st power, and b to the -3rd power raised to the -1st power. And you notice how everything, I don't know why I just put those parentheses there. They don't need to go there. It goes with, you see the -1 is with everything. -1 is with everything. So -6 to the -1st becomes -6 to the -1st. And it does need to have parentheses around it because it's a -6. Now, if we have a to the -2nd power raised to the -1st power, you know if you have a power raised to a power, you multiply those. So -2 times -1 will give you a +2. On the bottom, 3 to the -1st power, a to the -1st power, and right here, b, -3 raised to the -1st power. We're going to multiply those, so we're going to get b, -3 times -1 is a +3. And so what are we going to do from here? Well, equals, let's put our fraction bar. Let's look at -6. -6 has a negative exponent. So -6 has a negative exponent. So if -6 is on top of the fraction bar, it goes to the bottom. A has a positive exponent, so it stays on top. Or, I'm sorry, that was a squared. That stays on top. Now go to the bottom. 3 to the negative first power. Well, it has a negative exponent, and it's on bottom of the fraction. So it goes to the top, and instead of having a negative 1 for an exponent, it has a positive 1 for an exponent. And I don't need to put that in there because we don't need positive 1 exponents written in there. A to the negative 1 exponent, well, it has a negative exponent. It's on the bottom, so then it moves to the top. And it has a positive 1 for an exponent. B to the third already has a positive exponent, so it stays where it's at. And so now we can do some simplifying here. Well, we know a positive divided by a negative is going to give us a negative. And if we look at 3 divided by 6, 3 divided by 6 would be 1/2. A squared times a, they have the same base of a. And you add those exponents. 2 plus 1 is 3. And on bottom, b cubed. Now your answer shouldn't look like this. This is close. You're real close to being finished. But remember, on the top of the fraction bar, what is 1 times a cubed? It's a cubed. So this is what your final answer should look like. Negative a cubed over 2 times b cubed. That's what your answer should look like. All right, I'm going to show you the second method on how to do this. I'm going to leave the first answer up. Leave the first answer up. That way we can make sure we have the same answer in the end. Okay, if we look here, we are supposed to have, we have a negative exponent, a negative 1 here. So if we look at that one, you can look at that, and we know that the definition of negative exponent is the reciprocal. So what is the reciprocal of what's inside the parentheses? Well, basically what you do is everything that's on top goes to the bottom, and everything that's on bottom goes to the top. If you can remember, a negative exponent is the reciprocal. This will help you out. I think this helps you out in this example, this type of problem, because I think it's easier to work than the previous method that I just worked for you. And then from here, positive divided by the negative gives you a negative. 3 over 6 reduces to 1 over 2. A has a positive exponent. A to the negative second is on bottom, so it goes to the top. And b to the negative third is on top, and it goes to the bottom. So if I look here, I'm going to have negative. I'm going to have the negative. A to the first times a to the second is a to the third, which is what we have in the answer. And on bottom, 2b cubed. That's what we have. Same answer. Hey, good job. I don't know which method you like to use. Either method is fine. You still get the same answer. Sometimes you may use the top, sometimes you may use the bottom method. However you use it, you just have to make sure that you get the right answer. And you have to try and figure out the answer to the question of why did the duck cross the road? Why did the duck cross the road? Well, the duck crossed the road because the chicken had the day off. Chicken can't work every day. He's got to take some time off. So then somebody has to step in, cross the road. That would be the duck. So that's where we're at. This next example, I want you to try that one. Let me see if I want you to try that one. No, I'm going to have you try the last example on your own. Let's try this example together. Um, all right, so if we look here, 30 is going to get a negative 2 exponent. So 30 has an exponent of 1. So 30 times 1, or I'm sorry, 30, and then 1 times negative 2 is negative 2. X to the negative first times negative 2. Well, what's negative 1 times negative 2? Positive 2. And then y to the third, and then 3 times negative 2 is going to be negative 6. So this is how you can simplify this a little bit quicker and to still get the right answer. All right, well now the negative 2 went with everything on top, now it's got to go with everything on bottom. 12 has an exponent of 1, so 1 times negative 2, negative 2. X has an exponent of 2, so 2 times negative 2, negative 4. And y has an exponent of negative 5. Negative 5 times negative 2 is 10. And so this is where we're at. If it has a negative exponent, we move it to the other side of the fraction bar. So 30 will get moved to the other side of the fraction bar with a positive 2 for an exponent. X squared stays on top because it's positive, and y to the negative 6 will move to the bottom, and it becomes a positive 6 there. Okay, now let's look at the bottom numbers. 12 has a negative 2 exponent. It goes to the top with a positive 2 exponent. And I have written it there above 30 because 12 and 30 are going to reduce, or I'm sorry, 12 squared and 30 squared will reduce here soon. X to the negative 4th, it's on bottom with a negative exponent. It goes to the top. And y to the 10th, it's on the bottom with a positive exponent. And since it's positive, it stays where it's at. Okay, so if we look, let's look here. Let's do some simplifying. 12 squared is going to be 144. X squared times x to the 4th, they have the same base of x, add the exponents. 2 plus 4 is 6. 30 squared is 900. Y to the 6th times y to the 10th, they have the same base of y, so 6 plus 10 is 16. This is where we're at. And we know 144 divided by 900, we can reduce those. If you're unsure of what numbers you can reduce them by, just think back here, 12 and 30. You could reduce 12 and 30 by 3, right? So, but remember, it's 12 squared divided by 30 squared, so that means we could reduce it by a 3 squared, which would be 9. So 144 divided by 9, what's 144 divided by 9? Something like 16? I probably don't want to write that there. I want to write it here. 16. Okay, and 900 divided by 9 is 100. We have x to the 6th and y to the 16th. And can we reduce any further? We can't reduce x and y because those are not like terms. But 16 over 100, we know they're both even numbers. So let's divide each one of them by 2. Divide each one of them by 2. 16 divided by 2 will give you 8. 100 divided by 2 will give you 50. Both of those are also even, so dividing by 2 again. 8 divided by 2 is 4. 50 divided by 2 is 25. 4 and 25 are not both even. So you can't divide them by 2. What about 4? 4 goes into 4 once. 4 goes into 25. Not evenly, it does not. So here's your answer. 4 over 25, x to the 6th, y to the 16th. And that's what your final answer should look like. Okay. The other method, well, we know that negative exponent means reciprocal. So if you're going to do it this method, everything on bottom goes to the top, and everything on top goes to the bottom. And remember, it would have been a negative exponent, so the 2 becomes positive. Let me flip back a page here for you. If you look at this exponent right here, the exponent of negative 1, it's still here as positive 1, because remember, 3 to the first power is still 3, and a to the first power is still a to the first, and so forth. So in this example, the 2 now, the exponent of negative 2, will become positive 2. And so from here, a couple different things. You can either work, these negative exponents, like you can work those now, or you can work them later. It might actually benefit us to work them now. Let's go ahead and do that. Let's go ahead and work with those now. You could bring this down with everything first, or you can do what we're going to do. Either way is a good way to go. Let me show you this way, and so you're ready for it. 12 divided by 30. I know 6 goes into 12 and 6 goes into 30. So 6 goes into 12 twice. 6 goes into 30 5 times. I have x squared on top, and it stays positive. X to the negative first on bottom, well, I know it should move to the top. I have y to the negative fifth on top. I know it should go to the bottom and become positive, and y cubed is still on bottom. And don't forget, the 2 is still outside. And so from here, let's do some simplifying. We're going to have 2 over 5 still. And we have x squared times x to the first, x cubed. Y to the fifth, y to the third, they have the same base, so you add the exponents. And so now that power of 2 goes with everything inside. The power of 2, so what is 2 squared? That's going to be 4. What is x cubed raised to the second power? Well, multiply the powers, the exponents. 3 times 2 gives you x to the sixth. Now, 5 raised to the second power will give you 25. And to the second power, y to the eighth to the second power here. Multiply those exponents. 8 times 2 is y to the 16th. So there's 2 methods on finding the answer. The third method would have been if you would have taken and put this exponent with everything first. That would have been the third method. Let's look here. Here's one. I want you to try this one on your own, and I want you to see if you can come up with the solution. Pause the video and then see what you can come up with. All right, I'm looking at this problem. From the very beginning, I'm looking at the problem. I see on inside the parentheses, I see 45 divided by 45. I know 45, I can reduce each one of these by 1, or I'm sorry, I can reduce each one of them by 45, so I'm just left with 1. They kind of cancel each other out. So, negative exponent means it's the reciprocal. So on top, I will have whatever's on bottom. And then on bottom, I will have what is on top. The exponent is still 3. All right, take that 3 and multiply all the exponents. So this becomes negative 24. This is negative 18, and this is 6. This one here is 12, and this one becomes 18. And so from here, we have m to the 12th, m to the 24th. The 24 was negative. This was negative power, so it went to the bottom. And this one here stayed down bottom. Okay. Remember, we've already used that, so we can scribble out that exponent of 3. So n to the negative 18th, it should also go to the bottom because it's on top with a negative exponent. And then on bottom, we have n to the 18th. This one came over. It was positive, so it stayed where it was at. And then we're left with p to the positive 6, so it stays on top. Go ahead and simplify this here. P to the 6th stays on top. M to the 12th, M to the 24th, they have like bases. They have the same base, so we add those exponents. 12 and 24 make 36. And n to the 18th times n to the 18th, they have the same base, so it's n. And 18 plus 18 will also give you 36. So, the simplified answer, p to the 6th power divided by m to the 36 times n to the 36th power. And I'll leave you with one short story here. Molly from Ohio in the United States of America wrote this and submitted it somewhere. And she said one day this man was driving along the freeway when he noticed a chicken running alongside his car. He was amazed to see that the chicken was keeping up with him because he was doing 50 miles per hour. So he pushed on the gas pedal a little bit and he got up to 60 miles per hour and the chicken was right next to him. He sped his car up to 75 miles per hour and the chicken passed him, left him behind. So the man noticed as the chicken was running that the chicken had 3 legs. He thought, that's kind of weird. So he followed the chicken down the road to the farm. Well, he got out of his car and he saw that all the chickens on the farm had 3 legs. And he asked the farmer what was up with those chickens. And the farmer said, well, everybody likes chicken legs. So I bred a three-legged bird. I'm going to be a millionaire. The man pondered there for a minute, and he thought, well, three-legged bird. Everybody likes chicken legs. Therefore, yes, farmer's going to make a little more money. Some ingenuity there. So the man came up with the question, and he asked the farmer how they tasted. How did the chickens taste? And the farmer said, don't know. Haven't caught one yet. Oh my. Well, if you guys have any questions, need anything explained, let me know. This is the zero and negative exponents of your math. Some good old chicken stories. So if hopefully you learned something here, and I will see you guys next time.